So for learning outcome 4.4, we learned about various continuous probability density functions. Specifically, the normal distribution was our most important one, and we calculated probabilities for normal distribution questions. Then, in learning outcome 4.5, we talked about z-scores and their relationship to the empirical rule to compare values and see if they're normal or not. Now in this last part, we're going to talk about how you can calculate a value from a given probability. So there's two types of problems in working with a normal distribution. When you're given some kind of score and you have to find the probability. Those are the ones we did here for the normal distribution, where you're told a student scored 85, or you want between scores of 62 and 70. So you're given a score and then you find a probability between 0 and 1. The other kind of question you can have is that you're given a probability and you have to find a score. Like if you wrote a test, what score should 75% of your students get? That type of question, where you're given a probability and then you have to find the score. To solve these types of questions, if you were doing them by hand, you can simply rearrange the z-score formula to solve it for x, the value of a score, instead of solving for z. Alternatively, we can use Excel directly. There is a function to do this called norm.inv. The inv stands for inverse. That just means it's the opposite or the inverse of finding the probability. Instead, we'll find the score. It works basically exactly like the standardized function, just instead of taking the x score, you have to put in the probability as the first argument in the function instead. I'll show you some different examples of how this function works in order to calculate scores when you're given a probability. The first question says, assume that this test scores or scores on a test can be modeled with the normal distribution. The normal distribution will have a mean of 169.13 and a standard deviation of 11.96. What value corresponds to the 80th percentile? So the meaning of the 80th percentile, we learned about percentiles earlier in the course, and I said that we would come back to them. So specifically, we talked about percentiles with the interquartile range. We said that a quartile breaks the data up into 4 pieces, but a percentile breaks it up into 100 pieces. When we're asking for the 80th percentile, that means what data or what score is 80% of the data below. So 80th percentile just means 80% of people would be below you. How you find the score for that is using our new function, norm.inv. You'd put in 80% as a decimal for the first thing. Then you enter the mean, and finally the standard deviation. And that's all you need to find the score given a probability. So when the question says 80th percentile, it's saying 80%. So we put that in as a decimal, and the score would be about 179.2 on the test, approximately. If the question instead asks what is the 10th or the top 10%, that question is saying if this was the distribution, we'd want this amount, that this would be the average, this is the x, 10% should be the area under the curve. What is the x that gives us 10% as the area under the curve? What's a bit trickier about this question is in Excel, the formula norm.inv is always built to give you the below probability, not the top probability, top 10%. So because it's built to give you the below probability, all you need to do is use your rule of complement. That if we want the opposite of the top 10%, that would mean that 90% is below you. The function in Excel, norm.inv, is always built for the below probabilities. So if 10% is above you, 90% is below you. And you would use that in the norm.inv function. The top 10% means 90% of people would be below you. And the score that you would get in that case is about 184.46 on the test. Finally, if the question just said the 10th percentile, I wanted to show you the difference between top 10 and 10th percentile. 10th percentile means 10% are below you. So anytime you see the word percentile, then you can just use that probability directly in the function. You don't have to use the rule of complement to do the opposites. 10th percentile means 10% below you, so you just put in the 10% into the norm im function, and that would give you a value of 153.8 as a score on the test. Please pause the video and quickly try these two questions on inverse values. When you press play again, I'll show you the answer. So the first one says a normal distribution has a mean of 50 and a standard deviation of 4. Determine the value below which 95% of observations occur. If we want below 95, that's what the norm.in function is made for. I know I use norm.inv and not norm.dist because I'm given the probability and I need to calculate a score. So the probability is 95, the mean is 50, the standard deviation is 4. The value below which 95% of observations occur will be about 56.6 if you're rounding. The second question says the amounts dispensed by a coffee machine follow a normal distribution with a mean of 250 milliliters and a standard deviation of 1 milliliter per mug. How much coffee is dispensed in the largest 1% of mugs? Again, this one we want largest 1%. So basically, if we have the mean being 250 in the middle, largest 1% would mean we're looking for the score X, where we have 1% bigger. In Excel, the norm.im function is not built for bigger questions. It's always built for less than. So if 1% is the top, then 99% are below that score. So how I would type this in to my norm.im function is I'd have to use the 99% below instead of the 1% above. I'd use my mean and my standard deviation of 1 milliliter. That gives me a score of about 252 milliliters, 0.3, in the largest mugs. To finish off this lesson, I just wanted to quickly explain how the functions we learned today for the normal distribution are all different from each other. The uniform distribution and the exponential distribution are also important, but for the whole rest of the course after study week, we're only going to be talking about the normal distribution. So it is important to know some differences between the normal distribution functions. First, if you're looking for the probability of something happening, you use norm.dist, where the first thing you enter is the value of x. For the probability, when you write true, this function will always give you the probability of being less than the x value. That means if you want a more than question, you have to use the rule of complement with 1 minus, and if you want a between question, you have to do 2 norm disks subtracted in order to get the between probabilities. If you want to solve for a z-score, so to be able to compare how many standard deviations away from the mean you are, remember z-score is greater than 3 are outliers, so if you want to look for outliers or anything like that, you can use the standardized formula where you enter the x score that you're concerned with, the mean and standard deviation. Finally, if a question is looking for the value of x, so the score, then you'll use norm.inv, the one we just learned about. In that case, somebody has to give you the probability, the mean, and the standard deviation, and you can use norm.inv to find the value of x from the continuous distribution. Those are the 3 important functions that we'll continue with after study week when we continue to learn more and more about the normal distribution. Thanks for watching this video, and if you have any questions about this content, please let me know because it will be essential to master this content before we keep using the normal distribution after study week. Thank you. Bye.